So we have started doing chemistry, and we have gone over the basics of chemistry. But what did we talk about today? We reviewed what?
Matter.
Everything is made up of matter. Correct. We reviewed mass, right, which is how much matter is in an object. And what did we go over today then? Yes, Caleb.
The different forms of water and its
states of matter. It's not just water.
And density.
And density, right, exactly. How much mass there is in an area. That's what density is, right? Okay, so this is what we've gone over today, and we are going to do 4 experiments. So our first experiment is slime today, and we're going to see how it behaves differently from other liquids. Okay, so our first step is to add 1.5 cups of cornstarch to the mixing bowl. Cassie, would you mind doing 1.5 cups of cornstarch, please?
Shoot.
It's okay. It's roughly, because this is 1.5 cups to 2 cups. So it's okay if it's a little bit, try to get as close as you can. Okay, so it says, what does the cornstarch feel like? So everybody take a little finger dip of what's on the table. What's on the table? And kind of rub it between your fingers.
It feels like plastic, kind of.
Kind of like plasticky?
Yeah, it feels a little powdery.
Powdery. Okay.
Kind of like squeaky. It's
A little squeaky, yeah.
soft.
Yeah, it's kind of soft.
It's kind of hard at the same time.
When you just dip your finger into it, and then kind of squeeze it between your fingers.
Oh.
Does it feel different when you dip your fingers in it versus when you kind of squeeze it a little bit?
I don't like it.
You don't like that feeling?
It's weird.
It is kind of weird.
Yeah.
Okay, so let's add our other ingredients and see what happens, okay? Next, Olivia, we need to add 1/4 cup of shampoo. Can you get 1/4 cup of shampoo? That is shampoo, not conditioner, right?
Yes.
Okay.
It smells nice.
Yep, that's 1/4 cup.
Okay, do we need a spatula for
It
the
smells
Just use that spoon that Cassie used for the cornstarch to, yeah.
nice stir?
Purple.
It'll probably make it a little slight shade of purple.
Kind of like a violet. It's
Yeah.
a big giant lava monster.
All right, Emily, grab the tablespoon and grab the cup of warm water. And you, Nathan, could take turns doing this. Go ahead and put maybe 3 tablespoons of water into our mixture. Get close to the bowl,
You want me to?
and you can kind of tip it. Oh, okay, you could do that. Yeah, it's fine.
There you go.
On.
Nathan. Oh.
All
Alright, now
3.
Nathan, hold.
Okay, Caleb, go ahead and start giving it a stir. Start stirring that up.
Is it
It's
getting
gonna be
thick?
purple.
Oh, it does look a little bit purplish.
That's because the shampoo's not mixed in.
It's like rock hard. Can I do more?
Let him kind of... Okay, do you think you need more water already, Caleb? Yeah. Okay, so hold on. Let Nathan do one. So scoot the bowl close to him.
Should I pour it for him?
Yeah, he can hold the tablespoon.
Hold the tablespoon over the bowl, okay, Nate?
Okay, hold still, Nate. Have him do 3 more.
Okay.
Oh.
That's okay. It doesn't have to be exact.
Oh.
3, 4,
Just a little bit. There.
3.
Okay, hand the bowl back to Caleb.
And we have to stand up. Good job, Nate.
I'm grinding up the bowl. I'm grinding up the bowl.
Here, try this.
Okay, what do you think, Caleb? Do we need more?
Yeah.
All right, Emily, go ahead and add 3 more.
Might need another cup.
It says add more cornstarch if it gets too runny, and add more water if it becomes too thick.
All right, so I think we need.
All right, Emily, hold up the water, please. So we've only added, we still have almost a half a cup left. And we are going to add more cornstarch because it's a little bit too runny. So go ahead and add just 1, yeah, there you go. Add 1 pretty decent spoonful. All right, and go ahead and stir, Caleb.
See if that makes it better.
Yeah, make sure you get all of it stirred in.
Oh.
Okay. Okay, we are going to pour a little bit into each bowl. Now, what state is this in as I'm pouring it?
Liquid.
Liquid.
This is so exciting.
It is so shiny.
Now, when I try to stir it, there is resistance there. Can you see that?
Yeah.
It becomes hard to push out of the bowl. It's flowing when I leave it alone. But when I apply some pressure with this spoon, you see that on the camera, Cassie?
Yeah.
All right, go ahead and try.
Ew. Oh, on the bottom feels like.
I can't
Yeah,
touch
don't.
it.
Oh, you want.
Oh, try it, Nathan.
Try not to touch your clothes. It won't stain or anything, but just try not to get too messy.
Nathan's like,
Ew, it's getting underneath my fingernail.
it's like a solid when I go like this, but then when they let it run,
Yeah, do it again, Olivia. So pick up some of that.
you pick up, but it feels like a solid. So
Yeah. It's running off of you. It's running off of you, but when you press it, it becomes
Who wants to play?
becomes like a
contest?
solid. Yeah, look at the little chunks in there.
And then
I can't. My hands.
Yeah, but then at the same time, if you let it rest, it starts to run off your fingers again, doesn't it? Yep, there it goes, like icing.
This is really hard to make.
I made one. Oh, I'm applying pressure. It's making a ball.
Yeah.
It looks like a Play-Doh ball. And it feels like one too.
Oh, yeah.
I got it. I got one. I'm on a roll. All my blue block is kind of like going off the table.
It's like flinging everywhere.
Look at mine.
Yeah.
I feel like Play-Doh.
Huh? Oh, that's a big ball. But you can see it like when it starts relaxing almost immediately once you stop. Yeah, look at it kind of like melting into your hand.
Oh, Mama,
Yeah.
I got like a big ball. See, I'm going to make a worm.
Yep.
Oh.
Oh my. All right, so it says slime isn't your typical liquid or solid. Applying pressure to the slime increases its viscosity or its thickness. When you handle the slime gently, the starch molecules can move around, suspended in the water. This makes a slow-flowing liquid, kind of like our icing like we were talking about. But when you press down suddenly on the slime, the starch molecules lock together, making the slime feel more solid. Slime is an example of a non-Newtonian fluid.
Non-Newtonian fluid.
The viscosity of non-Newtonian fluids changes depending on the forces of pressure applied. Okay?
The weather report. Today will be sunny.
And
But
snow.
bitterly cold.
Very cool. All schools will be closed, so have a fun day today.
Kids.
Unless you homeschool. Oh well. All right, our next experiment is called liquid layers. And we are going to look at the different densities that different liquids can have. So we are going to build a colorful tower, they say. So the first thing we're going to do, and I think I will let the littlest one do this first part, Emily Nicole, because, well, the first layer is going to be the easiest to pour in. So grab the corn syrup. Nope. Corn syrup. Yep. Okay. Unscrew that. Or, yeah, it's like that. Yeah.
That brings back memories.
Corn syrup brings back memories.
When we used to mix butter and corn syrup it would make an amazing thing to put on bread.
Yeah, that's what your daddy does. Yeah. I had never heard of that. Softened syrup. Okay.
That's what it's called.
All right, Emily, I think we're going to pour to about, maybe right here, okay?
This stuff is amazingly sticky.
It is amazingly sticky. A little bit more. That's, okay, that's good. Olivia, you could do the next part. Pass the glass to Olivia. Yep, and it's going to be the water. Now, this is just water with some blue food coloring. You can also use honey or maple syrup as your bottom layer, it says. But the thickest I had was that corn syrup. Very slowly. Slowly. Slow pour.
Oh, wow. Ooh, it's blue.
That's actually really cool.
It's so blue.
That's real pretty.
You have to do a really slow pour so that you're doing fine, Olivia. Keep going. So that keep going, Libby. They don't start to mix. So you actually create the layers. Okay, and it says to pour the oil on top of water. We know that oil and water do not mix correct? So the same thing, Caleb, you're going to have to do a pretty slow pour, okay? And it will probably go in a little bit, and then it should float back up to the top, so don't worry too much. But
Oh, cool.
yeah.
Oh.
Okay, let's do that. Yep.
Oh, I see it
All right.
waving around. That's cool.
Yeah.
We did too much corn
If you
syrup.
look on top,
All right.
you can see this purple. If you look down below, you see yellow.
Yes,
Look
so
at that. You
that's
just
right.
see blue because it's kind of clear.
Yep, if you get it straight on, you can see the different layers of the corn syrup, the food coloring water, and the oil up on top.
Yeah, do we have to drink it?
Fuller is, but more fuller is redundant. No, you're not going to drink it.
We're done.
Okay, so we have got 8 items over here. We have a piece of chalk, a carrot, a peanut, a pumpkin seed, a marshmallow, a penny, a bean, and a bead. So there are 4 kiddos because Nathan is down for a nap. And we are going to put the things in there one at a time. So Cassie hasn't done anything, so she can go first. Cassie, which one do you want to try?
I'm gonna do the chalk.
When you drop it in
Slowly.
gently. Don't throw it, okay?
I do it like that,
Yeah,
or
that's fine. It doesn't matter. Oh, okay. So what happened? What level is it in?
floating. It's in the oil.
It's on
It's
the
floating
top.
on top of the oil, huh? You can see a little piece.
Yeah.
Yeah, you can see a little piece on top of that right there.
Only
Yep.
a tiny bit of pieces.
Okay, so what does that tell us? Is chalk dense or not very dense?
Not very dense.
Not very dense, correct. Okay, what do you want to pick, Emily? You're next.
I'm going to do the penny.
The penny, okay. All right, let me get ready.
Wait.
And
What do you think it's gonna do?
Yeah, what?
I think it's going to do the middle.
I think it's gonna
Yeah, I
go
think
down
it's
to the
going to
bottom.
be like here.
Yeah, it's
bottom.
gonna go to the bottom, I think.
Oh, I kind of stuck.
yeah, it also pushed the chalk down a little bit. But what's going to happen to the chalk, do you think, over time?
I think it might sink. It's gonna dissolve.
Do you, why? Do you think it's going to take on some of the liquid?
Yeah.
Yeah, it probably will because it's pretty porous. But yep, the penny sunk all the way to the bottom of the corn
So
syrup.
it's very dense.
So a penny is very dense. All right, Olivia Lynn, which one do you want to do?
It's like there are two
Okay.
pieces of chalk down there.
What do you think is going to happen, Liv?
Gonna go to the middle.
Really? Okay.
I think it's gonna float.
No way.
It's gonna float.
Yeah, it's gonna float.
All right, go ahead.
Like, whoop.
Yeah. Just like it does in a cup of hot cocoa, huh? Now, same thing as it
don't wanna
becomes
drink that.
as it becomes waterlogged, it probably will sink. Don't do that.
Probably edible. But
It will probably sink a little bit as it takes on the oil, but the density of the marshmallow itself, by itself, will float on top of the oil.
you don't
All
want
right.
to drink that.
Caleb's turn. What you gonna pick?
The
Probably
carrot.
The carrot. Okay, what do you think's gonna
I was
happen?
gonna do that.
I'm gonna think it's gonna sink all the way down to the bottom because it's
Okay.
a little heavy.
Okay, it's pretty heavy. Weight doesn't always mean density, does it?
Oh, it's floating.
It's in the middle there.
Oh yeah, it's kind of floating on top of the
Oh, it's
water,
coming down.
isn't
It's
it?
coming down.
Oh yeah.
Oh,
there
so is
it
the
goes
chalk.
a
So is
little
the chalk.
bit.
So is the chalk.
Oh, the chalk.
Oh, the chalk.
Is it
it's
always kind of
stinging.
coming
It's
with it, huh?
stinking.
Wait, it came down
Look,
this.
it's chalk.
Okay,
There's
where-
chalk.
Okay, hold on. Turn the. Where is the carrot?
The carrot's right there.
Bottom.
Right there. You can see it right there.
Oh yeah, there it is.
And then there's the chalk right there on top
Okay,
of
so
it.
it is floating on top of the corn syrup right now. So which one is more dense or denser? Is the carrot or the penny?
The penny.
Denser.
penny.
The penny is denser. That's
Oh,
correct.
the chalk's falling.
Is the chalk going now too? Oh, yep. There goes the chalk beside the carrot.
Oh, come on, chalk. Come on, chalk.
I think
All right.
chalk's going to win.
But we know that the chalk by itself floats, right? It's just taking on some of the
Oh,
liquid.
it's falling down. All the way.
Okay, we're back to Cassie. Cassie, what are you gonna do?
I don't know.
And you can see that the
I'm gonna do the bean thing.
The bean or the bead? Is it the bean?
the bean.
Oh, the bean. Okay, go ahead.
Bean.
Oh,
Where's it going?
It's in the
Where
middle,
is
I
it?
think.
Oh, wait, it's falling. It's falling.
Oh, it's falling.
I can see it.
Okay, it's kind of resting on top of the corn syrup is where
Did
it
it come back
is.
up? Where is it?
No, it's on this side. It's right here.
I can't see it. Let me see it.
It's on the same league as the carrot.
Oh, is it slipping?
No, it's kind of staying still. Yeah, you can turn and look at it.
still floating.
Oh, you see it. You see it.
It's gonna fall.
Oh no, I can see
It's
it.
like on the
All right, Emily, what do you gonna pick? The peanut, the bead, or the pumpkin seed?
I I think I'm gonna do pumpkin seed.
Pumpkin seed. Okay.
It's gonna float, I'm guessing.
All right, go ahead.
I think it's gonna float and then sink maybe like very slowly.
Kind of like the chalk and the.
Oh, yeah.
Oh.
Yep, floating on
I'm
top.
gonna do
Yep.
the peanut.
What? Where's the chalk
All right.
now?
Peanut.
Oh, it's.
No.
I think it's gonna stay
All right, this
there.
is the peanut.
Oh,
Oh,
It's-
it is resting on top of the water.
But
So
it's
it went.
slowly sinking.
It went through the oil and it's resting on top of the water.
I don't see one of these fall down. Let's see. Alright.
well, what happened if we shook
Finally,
it up?
I got the.
It would probably mix.
feed.
That stuff would mix.
Yeah,
The
but what
layers
would
would
it
mix
look
up.
Like?
No.
We should do it.
Anyway, is this the bee? This is the last one, Caleb?
This is the bead.
All right.
I wonder what this is gonna do because it's light as a feather, but it doesn't mean it's not dense, like you said.
Right. Weight doesn't always equal density.
I think it's gonna be like
Okay,
a
can you
peanut,
go ahead and
sink a
do it?
little bit.
All right, I'm not sure what this is gonna do.
Oh,
It floats.
it's floating.
Oh wait, no.
Oh,
sinking.
it's sinking. It's sinking.
Sinking.
It's going down into the water.
It's like right there.
Oh, I think I
Oh,
see
it's
it.
sinking now. It's more sinking. Do you see it?
Oh,
Yeah.
keep the marshmallow.
Keep turning. Oh. So I think this is it. Yep,
Yeah.
there it is, right there. It's on top of the water right now.
Hey,
It looks
if you
like.
look down, I think you can see all of it.
Well, you
No.
can't see through the water. All you can see is the stuff
So
through
are we
the-
gonna mix it
on
up?
top of the oil. All right, our last experiment for the day is called the growing marshmallow. Nathan is going to join us for this one because he woke up from his nap. So it says that we are going to create a marshmallow monster in our microwave. Okay, so you each have a large marshmallow, and the first thing we're going to do is mark which ones are yours. They say to use food coloring and toothpicks. We are just going to do markers. Okay? So everybody go ahead and decorate your own marshmallow. Make a face on it or a pretty flower. Whatever, however you want to decorate. Drawing on these marshmallows will also help show the expansion that's getting ready to happen in the microwave because we'll see our small pictures blow up into big pictures. Won't we? Okay, when you finish, go ahead and put your marshmallow on the plate. All right, here are our marshmallows. We've got Olivia's. This is Caleb's. Cassie's. Nathaniel's.
You tell what it is.
And Emily's. All right, let's go put them in the microwave. Okay. Go ahead, Em. Close it up. Ignore our messy microwave. All right, and we're going to do for 30 seconds to get them as big as possible.
Oh, cool.
Holy cow.
Oh, they're so big.
Hurry.
Whoa, look at those. Okay, I'll pull them out.
Oh
And now they're deflating.
Mine actually looks kind of cool.
Yeah.
Marker's coming
Don't touch,
off.
they're probably very hot.
Can I take a look?
No, you can't take a lick. There's marker on there. All right. So it says marshmallows seem solid, but they have lots of air bubbles in them along with sugar and water. When they heat up so quickly, the air bubbles expand, pushing against the stretchy walls of the molecule. And the marshmallow expands, okay? Then they also have a kind of a fun fact underneath here, too, about the marshmallow plant. Is a marshmallow a vegetable? Not quite. So this is a marshmallow plant. Mixed with honey, the root of the plant was used medicinally to soothe sore throats. In the 1800s, the root began to be mixed with sugar, water, and egg whites to form a candy. Over time, however, gelatin began to replace the marshmallow root in the candy that bears the plant's name. So today, marshmallows don't have any marshmallow in them, but traditionally, they were made with the root of the marshmallow plant. Okay? So that is our lesson on density and the states of matter today. Pretty cool experiments, huh?
Yeah.
Yeah.